Hey everybody, this is Larry. This is day 6 of the August Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm. Today I am out of breath. I just did 9 miles. You can't even find the button. I did 9 miles on a speed day, 1.5 miles warm up, 1.5 miles cool down, and then did like fast slow lap, and I am just beaten. I had so much trouble breathing. I'm so out of shape that I don't even have my voice for right now, is why I brought it up. But yeah, anyway, yeah, and it is still very hot here in New York. Actually, maybe not that hot, but I am balled up anyway. So yeah, so my apologies. I'm not. Every time I don't wear a shirt, you don't see anything other than like my collarbone or something. I get comments about, sometimes good, sometimes bad, but nonetheless, here, now I have a shirt on, kind of, right? It's actually, it's a, just gotta put a shirt on top of my body. So does that matter? I don't know. I don't know. I'm just amusing myself too much. But today, let's take a look at today's problem. We have 3479 fruits into baskets 3. I guess it's similar to the one you did yesterday. It's maybe an upsell. Let's take a look. My apologies again, and my voice is. I didn't expect my voice to be so bad, but I guess I was, yeah. I was breathing. I was running hard on speed day, so I was breathing hard, and I think maybe I can't. I don't have my voice right now because I just ran it. But yeah. Okay. Well, I took a shower because otherwise I smell. All right, let's take a look while I drink. So read the problem to yourself while I read it. Yeah. I mean, I think I actually talked about this yesterday. Maybe. I kind of gave a hint, but I actually don't know if I talked about this yesterday in detail, to be honest. Or I knew I didn't put in detail, but I don't know if I put enough to solve. And actually, I don't know. I know how to do this because, well, in a spoiler alert kind of way, we talked about it yesterday and it was in my mind. And Leetcode didn't really hide the fact that we're going to do like a foodie series or whatever. And, because we had 2 yesterday, the ends are, what's it, like 100 or something? 100 or 1,000, I don't remember. So, but either way, much faster. But 10 to the 5th is obviously not going to be n squareable. I gave a talk yesterday about n log n, right? And I'm trying to think if there's like a dumber way. Because one thing that I is that it is a medium problem. So spoiler alert, the way that I'm thinking of is what do we call it, segment tree, and it's not even a easy segment tree per se, in that there is this idea of I call it binary search in the subdivision of the space. Some people don't call it binary search. That's maybe fair. You could call it segment tree walk. I think that's the idea that's off my head, but that's like a really involved solution for medium, and I only did this like not that long ago. I'm going to cheat and take a look just at the timing. It was only 5 months ago. And I almost certainly done it with the sig tree thing. I'm just trying to think, yeah. Yeah. I mean, that is pretty standard, and if you have the right segment tree, that is like a 5-line code plus the segment tree, right? I believe, though, to be honest, I think this is one of the first times in the video or on my video on YouTube's that I actually explain segment trees, what I call the segment tree walk. Like I said, sometimes I don't know, I call it binary search, but people give me a lot of crap about it last time. I mean, it's not binary search in the traditional sense, of course, but you're bisecting the space you're searching. You can maybe do a search on that, but honestly, I think I gave a lot of effort on the last time I did it, so I don't know if I want to reiterate that video. I'm going to take a hint for a second, just to because I'm trying to think whether there's a non-segment tree solution, because this is a ridiculous problem for Medium if it's true, right? Hopefully that's fair, and I know how to do it, and it's just not that interesting to me if I have to, you know. Yeah, okay, they're saying to do a segment tree. I don't. Oh, I see. They actually have a different idea than the one that I was going to do. Yeah, this is a different idea than, I mean, it is still segment tree, but it's actually not the core segment tree, if you will. Yeah, I don't know. I'm gonna tell you what I'm gonna do. To be honest, I don't do this often, but one, it's a tiring day. Two, if I remember correctly, I put a lot of effort on this the last time I did it. I go over all the examples. I'm just gonna paste this, or the other way around, paste that video into here. Because every time I put a link, people are like always complaining on how to find it, etc., etc. But just to be clear, they mark it as a medium, but it's a hard problem, and it's a problem that I don't know. If you say 5 years ago, and by then I was red top coder or whatever, and I only say that not to brag, but just to point out that like at that point I wouldn't know how to solve it. I didn't know segment tree at that time, and even like probably 2 years ago, maybe 2.5 years ago, 3 years, I knew segment tree, but only in a template kind of way, and I mean, I guess I would have solved it with binary search, which is n log square n versus n log n, but this is a ridiculous problem for Medium, a ridiculous problem for a daily problem even. And I could like just repeat what I said 6 months ago, but I'm a little bit lazy. I'm not feeling it. I just ran 9 miles. So yeah, but I'll do the lazy work for you and put that video here next. But yeah, one more thing I'm going to say is just that, yeah. Like, this is ridiculous. If you don't know this one, it's fine. Don't worry about it. It's one of those, like, what I call, if you get it in an interview, there's one of two things. Your interviewer know how hard it is and hates you. Or two, your interviewer is an idiot and don't know how hard it is. Either way, maybe, you know, it's just not your day and I apologize. But, you know, I would consider this one of those problems, to be frank. And yeah. Yeah. Without further ado, thanks for watching. You know, I'm going to show you past Larry. So the current Larry will wish you stay good, stay healthy, to good mental health. And yeah, I'll see y'all later and take care. And here you can watch me solve it during a virtual contest or whatever, with an explanation next. Hey everybody, this is Larry. This is me going Q3 of the weekly contest 440, Fruits into Baskets 3. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So settle in. This is probably going to be a little bit on the longer side, mostly because it deals with segment tree. And yeah, I'm going to assume that you read the problem and you understand what it's asking for. I don't think the understanding part is that difficult for this one. It's just that for each number, you have to find a number to the right that is not, you know, big enough, right? Or that is big enough, sorry, and not used yet. And the short answer, honestly, is going to be segment tree. I'm going to go over segment tree really quickly, right? But if it's too fast, there are other videos on segment tree. I don't like to go over it. I don't think it's necessary. It should be necessary for interviews. It's just that Leetcode has been dumb, and Q3 with seg tree is just ridiculous if you ask me, right? Anyway, the way that you would think about it is that it's just a tree, and the top node you have from 0 to n minus 1 inclusive, right? And then now you have the left tree and the right tree. On the left tree you have 0 n over 2. You could say n over 2 plus 1 n minus 1 inclusive, something like this. I mean, you could say off by 1 or whatever, and then you have tree that goes forward, right? And then the idea here behind so first of all, what you want in this case is a max update tree, right? And what I mean by that is that on update, actually let me step back a second. So this is a segment tree that's and for each of these nodes, for these segments, if you will, it would contain the max of these elements, right? So basically this node would contain the max from 0 to n minus 1. This node would contain the max from 0 to n over 2, and so forth. And you could kind of see the divide and conquer version-ness of it, right? You could write it out as nodes and stuff like this, and you can see that, you know, you're going from left, you're going to the right, you know, you see what you need to do, right? And of course, you can kind of figure out the max recursively, right? So then all the way down at the bottom, there's going to be one node, right? So, and that one node, or node with one cell, right? Then maybe it could be some number, right? Like this is 2, this is 3. Then now if it propagates back up here, all you have to do is just, well, merge the 2 and the 3, right? And you merge because you want the max. You just take the max of the children, which in this case is 3. And of course, because there's and I'm going really fast, like I said, because I don't want to stay stuck on the segment tree part, but apparently it is necessary. There are deeper videos, so definitely check those out. But yeah, but as you can see, there's gonna be log n number of things, so each update is log n, right? So that's kind of the core idea, right? Is that now you're able to get the max, you're able to have this tree, you're able to keep this tree, you're able to keep this tree in a consistently with log n entry, right? Because basically, for example, if let's say you want to update, let's say, okay, let me change the color real quick. Let's say you want to update this 3. Yeah, you want to update this 3 to something smaller or bigger, doesn't matter. But you want to update this to, say, a 4, right? Well, in this case, then now you just go up the tree. Well, 4 now is the max, so this is a 4. This is, you know, this goes up maybe not, right? Maybe this other number is bigger. But either way, it only goes up log n steps. So every update is log n, right? Yeah, okay, so that's fine. So how would you solve the thing where, you know, given this structure where basically for now you have 2 things, right? You have an update that is in log n, and we have maybe a query. You could say query is also log n, right? And what I mean by that is that you can kind of see that this is 0 to n over 2, right? Yeah. And to kind of get a max element from a prefix, you can just binary search for it, or you can query for it. For example, let's say you want from 0, you want to get the smallest, you want to get the largest number from 0 to 10, right? That is going to be log n from 0 index to 10 index 10. That's going to be log n because you binary search, and what that ends up being is that you probably just take the piece from 0 to 8 or 7, actually, sorry, off by 1, plus so you would take this node, merge it with the node with, like, I don't know, like 8 plus the node with 9 and 10 or something, right? Something like that. So you kind of merge at least or at most log n nodes, and you could kind of Yeah. You do at most log n nodes, right? And that's it, right? And you're able to get the max for the prefix, right? I'm going a little bit fast. I'm just thinking about how to slow it down, or which parts I need to slow it down. And the way you do it is just by query. On a query, you in a straightforward, quote unquote straightforward segment tree, you would just do it by, you know, like for example here, we go, well, let's say we query for 10, right? Or we query from 0 to 10, or we want to query from 0 to 10. Well, maybe we go here, and maybe this node is 0 to 7, right? Yeah, 0 to 7. Then what happens is that at 10, it knows that left is going to be 0 to 7. So then it takes the max of this part, so just this node, and then here on the right side goes from 8 to 10, right? And maybe 8, like I said, maybe 8 is one node, and then another node is 9 to 10, and then you just kind of merge them all together, right? And technically it won't be 9 to 10, and the 9 will go 9 and 10, but here it would encompass the entire node, so then you don't need to go any further maybe. But yeah, I'm going really fast, like I said, but these are the ideas behind segment tree, right? And the problem with this is that, okay, each query takes log n. So here, maybe an idea is that, okay, so for every fruit, we binary search for the basket, right? We go, okay, well, change the color real quick. So here, maybe, let's say n is equal to 20. Then first we go, okay, well, what is the maximum number from 0 to 10? If this is bigger than our fruit basket, then that means that the answer is within this half, right? So then maybe we'll binary search for 0 to 5. If it's not, then and it's going to be from 0 to 8, 8 being between 5 and 10 or something like that, you know, rounding errors, and then so forth, ... So then now, if we know that it's 0 to 9 is, or whatever has the fruit basket that is bigger, then we know that the answer is going to be 9, because that's the first instance in which the number is bigger than or equal to the fruit basket, right? And of course, in this case, you have log n here, log n number of queries here, but each of these query also is log n. So now this is going to be in total n log square n, which I'm told that in Java, am I writing too confusing? I don't know. Hopefully the colors help. But I'm like that conspiracy theory guy, just like drawing craziness all over the board. Hopefully this is understandable. But in any case, there's going to be n square log n, or n log square n, which I'm told is fast enough in Java, but not Python, right? I don't know. It is what it is. So how do you make it faster? And apparently in Java you don't have to, but you probably want to learn this anyway if you're here, right? So now you have a top node, right? And then, like I said, let's just say this is a node of this is a 20, n is equal to 20, right? And then on the left side, this is going to be 0 to 10, 10 to 20, or 11 to 20, sorry, right? And then this is going to be 0 to 5. This is going to be 6 to 10, right? Pick a circle so I could write in it. 0 to 2, maybe? I don't know. I mean, rounding error doesn't matter, right? And then ... Okay, maybe that's enough for now, right? Well, the answer is, instead of binary searching it, you can actually just call walk the tree, right? And what I mean by that is that, let's say we're looking for f is equal to, the fruit basket is equal to, say, some number. It doesn't really matter, right? Like 20. Well, then here, then we walk by looking at the top node. At the top node, we go, okay, we know what we know what this node is, and we know what the value of the left child and the right child, right? Well, if the value of the left child, change color again. If the value of the left child is big enough, then we just go straight there, right? If it's too small, then we go here, right? Because we know that it has to be on the other side. And that's really the key thing, that it's actually not that bad to understand once you realize and once you visualize this and have it done. If you watch me solve this problem live, I did actually copy and paste a min seg tree, even though it has some funkiness to it. I don't know why. But you see me actually just working this out backwards or forwards. I don't know. You just see me working this out. So I didn't have, I did not, I have a segment tree template, but not a walking tree template, if that makes sense, right? So, okay. So, yeah. So, for example, if this case, it is, in this case, then now on this node, we know what the children's value is. So then we just decide to go left or right depending on children. And of course, as you can imagine, there is log n depth. So you only have to make log n queries to do it. This is where divide and conquer. People may say fancy things about it, how difficult it is, and I'm not gonna lie. strongly disagree that segment tree will be on interviews. In general, there's always a caveat for crazy Indian problems. Look, don't add me. I'm sorry. Like, but I disagree in fundamental that like people need to know it. But if you are to learn segment tree, and hopefully I kind of gave you a brief taste from earlier, coming up with the walking the seg tree, which is why you have a walk, it's actually not that bad, right? Hopefully you get that. And I mean, this explanation so far has only been 12 minutes, and I've gone much longer explanations before. So yeah, that's really the key idea. It's just divide and conquer, and we'll go over the code now, right? Okay, so let's say we have the segment tree. I just want to go over the idea first. So the idea is that, okay, for each fruit, we search the index, right? So if index is -1, which means that if it's not in the tree, right? If the entire tree does not have a number that's at least f, then we return a -1, I think. For this, and as a result, we just add count because then we're not matched, and then we continue. Otherwise, we want to update, and this is actually an ugly looking update, but that's fine, right? Anyway, we update that index, we set it to 0 so that it can never be max again in the future. That's basically it. And this is, of course, pretty straightforward. I mean, we'll go over the segment tree, don't worry. This is log n, and this is log n, right? Okay. So n log n, that's all we have. And I think this is n log n too. Yeah, maybe. No, this is all of n. I mean, yeah, on the build. But yeah. Okay, so let's go over this tree. Initially, we set up the tree. We have a build function, and the build function is very straightforward in terms of recursion, right? I think once you kind of, I feel like a lot of people try to use segment tree as a black box, and I'm saying that as someone who did do this. But once you have a visualization of what I did of drawing it out, it's actually not that bad. I think you can kind of come up with, like, yes, it's not great for contest time in terms of like solving it as fast as you can, but you can write this if you really try. I don't think, honestly, most people, like, we have binary tree knowledge. You could, I mean, the way that people write it is with this implicit node index, but you can actually, I don't know if it's faster for Leetcode, but you could write it as explicit node objects as well on the left side and the right side, right? So yeah. Anyway, so like you could have a left node and a right node, and it'll be exactly the same thing. But yeah, so we built the tree, and this is recursion, right? Divide and conquer. If the tree has, if the node has only one cell or one index, then we just set that node as that index. Here this is divide and conquer. We set the middle. This is the index value of the left node, 2 times node, and 2 times node plus 1. This is something that comes up in, I think, binary trees as well. So it is something that you could be able to get it. Yeah, and this is just the node index, right? And again, you can implement these with actual nodes if you like. But yeah, and then this is just we recursively build the left side and the right side, the left node and the right node. And then here, once we finish building, then the current node value is just the max of the left children or the right children. That's it, right? Pretty, yeah. I mean, the build part is pretty straightforward, right? Because we want to get the max of the prefix. And we don't even, and this doesn't even do anything with prefix necessarily. It's just a thing, right? It's just that we're using as prefix, but we don't have to. Okay, let's do the update next, right? Yeah, you could probably write a helper for this update. It's a little bit funky, honestly. But yeah, node, the way that there are 2 ways to write the node or write the tree, just like in a regular binary tree, right? Which is you could index it at 0, or the root node at 0, or the root node at 1. The root node is at, and it just changes whether left child is 2 times x plus 1 or 2 times x plus 2 or whatever variations. It's stuff that you ran over in binary tree stuff. But yeah, again, so root node to start off, the start index is always going to be 0 and n minus 1 because that's the value of the root node. That's the assumption. And then this is just setting up the index and value, right? And then here we go, and this hopefully, yeah, we have the left child and the right child and the middle. This is divide and conquer stuff. We are pretty straightforward. And then now for this index, we just want to see if it's on the left side or the right side, right? If it's on the left side, we update the left side. If it's on the right side, we update the right side. And then that's it. And then after we update it, we re-update this node and then recursively update when you pop back up, right? And this function is going to be log n, right? Because we only update one of the branches and we only go through, and each of these, every time we do a recursion, you divide the things in half, right? This is divide and conquer stuff. So this is going to be log n. So update is just log n. Bill is actually O of n because this is almost like, if you really want to think about it in terms of trees, it's more it's like traversing the tree, right? So this is going to be O of n because it is traversing the tree, but you only call Bill once, so that's why it's fine. Okay, and then query is the part that is actually different. Like everything we've done so far is standard segment tree. You know, you should be able to write it from scratch. It's just a lot of typing. Maybe I should have though, because I had some debugging issues from my old one. I don't know what I was doing in my old problem. I just kind of found a random one. But yeah, so query just kind of sets this up. So basically what this idea is that find the first index that is greater than or equal to x, right? So that's what this does. And of course we again set up the root node, the starting index of that node and the ending index of that node. So usually I call it left, right. I don't know why I chose start and end actually. And then x, we just do it, right? So this is the same thing. It's just that I wanted this to be, I don't know, I thought it would be cleaner. But yeah, the reason why I had this here was because I was printing, I was debugging, so I was printing some stuff out. That's why I did this twice, whoops. But yeah, and then now this is, if x is greater than this tree, that means that, well, we just return -1 because it's not possible. And this would only happen if this is the root node, right? Because otherwise the invariant is that it is in the tree. So this only happens if it's in the root node and we just return -1. And then we return -1, we count it, and then we go on, right? Otherwise, if this is not true, that means that we know that one node in the tree, or one cell in the tree, one index in the tree contains a number greater than or equal to x. And so here we go, okay, well, if we only have one cell left, then this is the cell, right? Otherwise, divide and conquer stuff, is it in the left side or is it on the right side? That's all this is asking, right? Left side or right side. And if it's on the left side, then the left side will have a number that's bigger than x, then we want to go to the left. Otherwise, we know that a number is bigger than x or equal to, so if it's not on the left side, then it has to be on the right side. And that's it. This is also log n because we only recurse log n times because we divide it in half every time. And that's pretty much it for this one. Yeah, again, O of n iterations, log n, and we're done. I wanted to kind of, this is my segment tree code if you have a very good screen and you want to see it on one set. But yeah, that's all I have for this one. You could watch me solve it live during the contest and kind of implement this. Like I said, I don't think it's that hard per se, but I also don't think that, people should have to learn this for a Q3 especially, or Leetcode in general. So I don't know. Your mileage may vary. I think it's silly. Let me know what you think. And yeah, and I think relatively speaking, this code is pretty clean. I don't know. Maybe you could do it iteratively if you really want to optimize it more. But yeah, that's all I have for this one. You could watch me solve it live during the contest now. I've lost all sense of my confidence these days, honestly. It's kind of sad, but okay. So these are the same except for this is now 10 to the 5th. Makes sense. What am I doing again? Oh, find the leftmost basket that I can do. How would I do it? So for I, choose the leftmost. I mean, segment tree would work, but I don't know if it's fast enough. Log square, and I guess you could do a walk, but that's tough. I don't know. That definitely works, but I don't want to do it yet. What's another way? For 4. We want no, we want the first one, right? So that so then you have to kind of simulate. I don't know that you can do without simulation because of the matching. Okay. How many people got Q4? 3 people. Okay, I have to think about skipping at some point. But is there other way other than segment tree double binary search-ish thing, or what? Binary search or seg tree walk? Seg tree walk would definitely work. Where's my code for it? What part did I do it on? Is there a dumber way? 10 to 5 or 10 to 6? 10 to the 5. Okay. Where's my code? Trying to find my code for this dang thing. I've done this recently too, but is there another way without it? just write it from scratch. Oh, not from scratch, but have to make changes to this. My old code, okay. 18 is probably fine, okay. Yeah, okay. Is this right? I wrote this so long ago that no, I want this to be max, if nothing else. Why would it be? Yeah. Okay, this file looks right. Okay. Is this right? Actually, It's for my old treeways max. Is this right? Update left, update right. Okay, that looks right, reasonable. It's been so long. Okay, and then query is the hard part. This part I have to actually change maybe. So, X. Then now this will have to walk the tag, right? Or walk the thing. Okay, so any people's gotten it? People have done already? Cute. But okay. Okay, so you have to do right? So if trial is greater than or is it greater than or equal to or greater than or equal to x, then we want to go left. Right? Is it just return sub.query? Okay, else oh wait, that's not right. We want current child too, right? Okay, fine. No, right? So why did the template I have for this one a little bit weird? Is my query wrong? Yeah, it is wrong. Oh, well, I need a second query. I usually do left right. I don't know why I have it like this, but it's fine. I guess it's just whatever I was using at that time. It's 0 or 1. I was no. This is This is 1 based. Okay, so yeah, 0 and -1. So that is inclusive x, right? Okay, if x is greater than sub.tree of node, then we just return. Is it -1 or 0? Or infinity? We want to return the index, so let's just return -1. Okay, fine. Otherwise, query left child start mid is equal to right? Yeah, hopefully this is right. I don't even know anymore. Like the off by one stuff. I keep on saying right and left. I keep on confusing my terminology. Okay. So it has to be one of these, and then okay. So then now, if node, or if start is equal to n, then we have one node. If x is greater than, oh, the other way around. Well, I guess it's fine. Return start. Okay. And then now we want sig tree of. I put in the. I don't need n. How come I don't put it in the array on the build? What is wrong with me? Huh? What is all this stuff? What is my code doing from the past? I'm gonna get like 5 wrong answers on this just because it's been so long. Yeah, what is all this stuff? I don't know what I was doing. I mean, I was probably doing something for another problem, but I don't remember it. Honestly, okay, fine. We want it for baskets. Okay, yeah. For f in fruits, then we want to get self.query of f index is equal to this, and so is equal to and so that append index. Oh no, that's not right. This is a different problem. Count is equal to 0. Then if index is not equal to -1, or if index is equal to -1, then it's unfulfilled and we continue. Otherwise, then now we want update. What does my update look like? Node. One. Index value index to 0. And then return count, something like that. I don't know. Self. Why is this here? Whatever. I just put it here. What was I doing previously? I don't remember. Why? Larry's old code is very weird. Why do I? Index is equal to st.query. Like 2 positional arguments. What? Oh, this is wrong because I didn't. No, okay. So this is wrong. Why? key. So we're looking for X, right? Looking for a 2 or higher. We go from 0 to 2. Right, okay. Let's actually put this here. That's fair enough. Okay, what is, oh, it has no child. That's probably fine. 2, 2, 2. Did I, where's my, I don't even know how this update works. Array dot store, what? Oh, I mean, that's fine. Wait, this is, no, what is this going on here? But, okay, fine. I mean, I didn't do any updates yet, so that wasn't it, but what is my code doing? What was my old code doing? I'm just kind of copy and paste it. Okay. Oh, it should be, no. Oh, I see. No, it could be greater than or equal to, right? So if, so it, where's my code? Okay, so this is, okay, that should be right. No update. Did I have self again? 2 and 2, which is very wrong. Why? I'll put 2 and the index is 2. Is that right? 4. That's wrong. What am I printing here again? Start n, right? So 0 to 2. The 4 is not found, is very wrong. Why? 0, 2, we're looking for X. Oh wait, no, 4 is right? Oh no, there's a 5, Larry. Wait on. 0, 2, and then, oh, the am I fixing the update right? Update, no, oh, you in the build, right? Left child, mid plus 1, And I'm debugging too much sec-tree code, but maybe it's fine for learning. I need to learn anyway. I shouldn't need to update this, but maybe that's fine, honestly. Okay. Yeah, that should be right. So, okay. 0, 2. Notice 2, which is wrong, right? Built. I am not very good today. Okay, built. Node 2, node 1. Let's do starting. Zero to 2. Tree of node is 2. Why? Did I put wrong? Why is this? Oh man, I thought I fixed that, but I guess I'm just being dumb. That's why. Okay, that is a very dumb mistake. I was cleaning that up, like it wasn't like I copy and pasted in, and then but then I literally went back and dug into it. But okay, fine. Where's my output? Oh, here. Okay, 4 index 1, 2 index 0, okay, 5 not found, okay, good. 3 index 0, 6 index 2, 1 index 1, okay. So that's good. I want to try a big case first. Is that fast enough? 1 second. I don't know if it's fast enough, but it's fast-ish. Oh, I might have switched force, but that's... I should have took this out, actually. Oh. Huh. But, how can that happen, though? I thought that... Oh, because this thing, I should have had this thing first, that's why. That's a silly one. Okay, fine. But we should still probably take that out, just for... I mean, it would have given me the wrong answer anyway, but at least it would have been a different wrong answer. Okay. I knew that one, but I wasn't doing it. Okay, fine. Q4. What is my running time on that one anyway? 2 seconds. So I don't know if there's a faster way, but 230 people gotten it. I don't know if that's good or bad. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join my Discord. Let me know what you think about this contest, these problems, explanation, everything in between. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.